A good day, everyone. So today we are focusing on powers with the rational exponents. So when they're talking about the rational exponents, they simply mean a fraction exponents. So okay, let us do some exercises regarding that. So when they say, like, check here, we have example 3, exercise 3 actually, whereby they say simplify the following without using a calculator. So actually we are going to use a calculator, by the way, but then in a way whereby they won't see whether you used a calculator or not, because you were actually following step by step. You were doing step by step. Because right now, if I were to punch all of this into a calculator like this, it's 9 to the exponent 1 over 2, like this, it will get me to an answer which is 3. But then we are going to do that using a calculator in a way that they won't know whether you used a calculator or not, because we are doing it step by step. So check 3, we have exercise 3, which is A. The first thing, which is 1, let us do 1 over 2, 9 to the exponent 1 over 2, like this. The first thing that you're going to do, you're going to find the prime basis of 9, like what we were doing the last time, which is 9 equals to shift then fact. 9 equals to then shift, then you go to fact, which is 3 squared. There's going to be 3 squared, open bracket, 1 over 2, like this. Can you see we're doing it step by step, though we are using a calculator. Then from there, we know that this 2 is going to multiply this one. So simply, it will be like 2 times 1 over 2, like this, whereby this one is a fraction, is not a fraction, make it a fraction. Then this and this, the cancel, will be left with 1. So it's going to be 3 the exponent 1, which is the same as 3. Can you see that time we got 3? And this is our answer. Can you see we are doing it step by step in a way that they won't know whether I used a calculator or not. So guys, this is simple. Let me try to do another one, which one that seems to be a bit difficult. This one is this, so since we did this one, it means we've done this one, this one, this one, and this one as well. Let me just, for argument's sake, let me just do this one, f. So f goes like 64 into negative 1 over 3, like this. So here I think you are going to do the same thing. 64 equals to, then you go to shift, then fact, which is 2 the exponent 6, it's gonna be 2 the exponent 6, and is to the exponent 1 over 3. So it means that I'm going to multiply this by this, right? So it's gonna be 6 multiplied by negative 1 over 3. This one is a fraction, this one's not a fraction, you make it a fraction. From there, I'm going to say 3 into 3 is 1, 3 into 6 goes 2 times, then 2 times negative 1 is going to be negative 2, like this. So it's going to be 2 to the exponent negative 2, like this. And which we know that exponents are always positive, so it's going to be 1 over 2 squared, which is 1 over 4. Can you see that we are doing it step by step, though we are using a calculator? And then from there, let me do G. It's like a bit difficult. So G goes like 1 over 27 to the exponent 2 over 2 the exponent 3, like this. You're going to find the prime basis again. So it's gonna be 27 equals to shift then fact. Oh, I'm so sorry. 27 equals to, then go to shift then fact, which is 3 to the exponent 3. So it's gonna be 1 over 3 to the exponent 3 all over 2. To the exponent 2 over 3, like this. Remember, this one is multiplying this whole thing, right? This exponent. Remember, there's invisible 1 there, so it's going to be I'm going to take this one, then 1 times this is going to be 2 to the it's going to be 2 over 3, but then okay, so it's going to be 1 times this, which is 2 over 3 all over 3 as my base, and 3 times this, it's gonna be 3 times 2 over 3, like this. This one is a fraction, you make it a fraction, then this and this to be cancelled, be left with 2. I don't know if you still remember that even if you've got a 1 like this, there's this exponent whereby whereby when we have got a base, when say whereby we've got a base raised to maybe 200, the answer will still be 1. So that law still applies here. So on top here there will be 1 all over 3 squared, which is going to be 1 over 9. So can you see that we are simplifying actually using a calculator, but in a way that that is not noticeable that we were using a calculator. So we continue, guys. So we're going to be doing this, we're going to be using there's this law, it's called the root definition. So this is the law. So it's like this. It's n a to the m like this, which is a m over n, like this. So this is the law that we're going to use, the root definition. So let us try to do example 4. Okay, so example 4, guys, as they say here, write the following without the root sign. So they want you to write to write the like let's say we're doing a, we're not going to be using this root sign, so your answer should not have this root sign. That's what they are simply saying. So a, let us try a. So a, as they are saying, we have 4 and that sign like this. So here when they say we have to remove this one, so it means, did they say simplify, write down the following without the, okay, they did not say simplify, by the way. So I'm going to write this. So this is the law that we are going to use. So can you see that the a remains? So I'm going to remain the, I'm going to write the a as it is, and then from there you can see that this 6 goes on top, then this 4, I mean this 6, sorry, this 6 goes on top, then this 4 goes down. So this, now we have written it in a way whereby there's no this root sign. It's done. Then you go to B. Can you see it's easy? Let's try another one. Let's try the one that I think is difficult, since this one is easy. We did this one, this was similar. Let's try to do this one, which is C. Okay, so it's C, whereby it is a root a to the exponent 5, like this. So from here, okay, so can you see that there is no any number here? So if there is no any number, there's 2. There's 2, because remember this one is the square root. A square root has got a 2, like this. So it when there is no, so we call this a square root. When it is like this, there is 2. So remember, we're going to take this one on top, so it's going to be a 5 over 2, like this. So this is how we do it, guys. Then let's see, even this one, it is okay. Let us do f. So f goes like this, square root of x. So remember, as I've said, that there is 2 here, so I'm going to bring down the x. Then remember, there's an invisible 1 there. There's an exponent of 1, which is the invisible 1. So I'm going to take that 1 on top, then I divide by 2, since I said it's square root, I've got a what, a 2, like that. So guys, this is how we do it actually. Let me try. Now they say write the following with a root sign. So now we are going back. Remember, now they're giving us into this form, whereby we have to convert this form into this form again. So actually they want us to know how to use this kind of a or this root definition. So let me do number A here. So I've got A. Now they say write the following with a root sign. So we have got a to the exponent 5 over to the exponent 4 actually over 5, like this. And as I've said that, remember this m here, the numerator number of the fraction, see this numerator one, it goes here. So I'm going to take my a here like this, then this 4 here, then I write my root sign, then the 5 will be outside like this. This is how we write it. Let me try. Can you see that these are the same? So let me just do another one, by the way. Let me do which one? Let me do d. Okay, so d goes like this. It's x to the exponent 2 over 3. Writing it into the root definition, I'm going to write x. This one's gonna be x squared. Then the denominator one will be outside like this. Let me do another one. Let me do the last one, which is e. E goes like this: a 1 over 2. Then I'm going to take the member, it's going to be a. Right, as I've said that this one it means a square root, so there's no need for me to write a 2 here, because a square root on its own, it means a 2. There's a 2 there, and but invisible one. So when it is like this 2, remember I was supposed to write this 2, but since we know that a square root of a 2, it's going to be a, like it's going to be square root of a like this. So when you want to go back to this form, we know that there's an invisible one there, whereby that one goes on top, then this one, the square root one, it is a 2 divided by 2, like that. So this is how we do it, guys. Let's see. They say simplify the following without the use of a calculator. So this is the same as the one that we did here, but this I think it is similar, by the way, with this one. It is similar with this one. Okay, let's just do some of the questions on this question. Okay, so we're on number 3 now. So number 3, we have got let us do this one, number 8, 3a. It's gonna be 3a. So we have got cube root of 8, this the exponent 4. Right, so remember, guys, we're still using our root definition. So it's going to be, I'm going to say 4 goes on top, so it's going to be 8. 4 goes on top, then over 3, like this. Then from there, we're going to find the prime basis of 8. As we all know that we say 8 equals to shift, then fact, which is to the exponent 3. It's going to be 2 to the exponent 3, close bracket, open bracket, close bracket, to the exponent 4 over 3, like this. As we know that this 3 is going to multiply this whole thing, so it's going to be 3 multiplied by 4 over 3. This one is a fraction, you make this one also a fraction, this and this, they cancel, will be left with 4. So it's going to be 2 to the exponent 4. Then from there, you take your calculator, you write it. It'll be 2 to the exponent 4, then you write, so you get your 16, like this. So can you see that we are using a calculator in a way, we are using a calculator, but then we are doing it step by step. So by doing this, they want to know whether you use the calculator or not. Okay, let me see. This is the same as that. This is the same as this. So let me try to do this one. Number D. So number D goes like this. For the square root, a bigger one, and we've got 1 over 4, close bracket, to the exponent 3, like this. And as I've said, guys, we're still using that definition rule of ours. There's a 2 here, so it's going to be 1 over 4. Then this one goes becomes the numerator, that 2 becomes the denominator. So from there, I'm going to find the prime basis of 4, which we know is gonna be 2 squared. These are the prime basis of 4 to the exponent 3 over 2. Then these two multiply that, so it's gonna be 2 multiplied by 3 over 2, This one is a fraction, you also make it a fraction. This and that, they will cancel. And we know that even if we multiply these terms, that our answer will still be 1. So it's going to be 1 on top all over. So we said cancel and cancel, so I'll be left with 3 here. So it's going to be to the exponent of what? Of 3, like this, which we know that's going to be 1 over 8. Alright, so this is how we do it, guys. This is our answer. Let me try to do another one that is different. Let us try number E. So E goes like this. We've got E. Okay, so E, I've got a square root of, we've got 3, like this, and the decimal 0.125, close bracket, -2, like this. So guys, this is how it is. So before you do anything, don't stress yourself. Just simply go to your calculator, you write those decimals the way they are. 0.125, like this. So can you see you're going to get 1 over 8. Then from there, remember that square root sign is still there, so you are going to get 1 over 8 -2, like this. Okay, let me make it bigger, like this. -2 to the exponent -2, like this. Oh, there's 3 here, sorry. Right, then from there we're going to use our root definition, whereby it says 1 over 8. This one becomes the numerator, this one becomes the denominator, like this. Then from there, we're going to find the prime basis of 8, which we all know that's gonna be 8 equals 2 shift then fact, which is 2 to the exponent 3, like that. So it's gonna be 1 over 2 to the exponent 3, -2 over 3, like this. So it means this one we're going to multiply that, so it's gonna be 2 to the exponent 3 multiplied by 1 over 3. Sorry, multiplied by -2 over 3. Then from there, this one and this one will cancel. I'll be left with, it will be 2 to the exponent -1 -2, like this. So it's gonna be 1 on top all over 2 -2. You know the reason why? Remember, this one will still be 1. So even if I say, we know that there's an invisible 1. Even if I say 1 times this, then the other will still be 1 actually. So from here, as we all know, don't forget, guys, we know that exponents, they are always positive at all times. So it will go up there, so it's gonna be 1 multiplied by this one, it is this one, multiplied by, I'm going to take this one over there, it's gonna be 2 to the exponent 2, which we know is going to be 2 squared is 4 times 1, which will still be 4. So this is our final answer. See? So from there, let us do another one. Let's see. Okay, so let us do another one. We are choosing, let's see, we did this, the one with the decimal one, we did it. Let us try number F, the one with the square root inside. So it's gonna be like this. So it's F. Let me write it here, guys, please. Okay, so I've got F like that, so which is open bracket square root of 2 close bracket 4 over 3, like this. Then from before you do anything, we're going to remove this exponent, this root. And as I've said that, remember there's 1 there, all right? So I'm going to take this 2 here, I take it here, and then this invisible, then this 1 will be the numerator. And I said that time that there's 2 here, it's gonna be 2, like this, all to the exponent 4 over 3, like this. Then from there, I'm going to multiply this together, right? So it's going to be, I'm going to say 1 over 2 multiplied by 4 over 3. So 2 into 2 is 1, 2 into 4 goes 2 times, so it's going to be 2 over 3. So it's going to be 2 to the exponent 2 over 3. So from this, we have simplified. Actually, there's no any further that we can go. This is the simplification. Let's try to do another one. Let's see. This one is similar to this one, but then we don't know about this one, so let us do that one as well. Okay, let me take another piece of paper. Okay, so we are doing this one, G. So G goes like this. G. Okay, G is square root of 3. This one 3 multiplied by 3 1 over 2, like this. So guys, before we do anything, we're going to remove this root. So as I've said, it's gonna be 3 and 1 over 2, like this. Exponent 3 multiplied by 3 to exponent 1 over 2. And I told you how we do this. We assume that it's 1 here, so that 1 becomes on the numerator, and I said here is 2 divided by 2, like this. So I'm going to say 1 over 2 times this, so it's gonna be 3 to the exponent 1 over 2 multiplied by 3. 1 times 3, so it's I'm going to take this 3 down the base. It's gonna be 1 times 3, it's gonna be 3 here, all over. Or this one is a fraction. This one is not a fraction. You make it a fraction. There's gonna be 1 times 3, which is 3, then 2 times 1, which is 2, multiplied by 3 with the exponent 1 over 2, like this, equals to. Now guys, can you see that the bases are the same? And I said that when the bases are the same, what do we do to the exponent? We add the exponent. So we are going to add the exponents on a piece of paper. It's going to be 3 over 2 plus 1 over 2, right? Can you see that we find the common denominator, which is 2, since the numbers are the same. 2 into 2 goes 1 times 3, it is 3, plus 2 into 2 is 1 times 1, which is 1. Then from them, we're going to say 1 plus 1, which is 4 over 2. Therefore 2 into 4 goes how many times? 2 times. So it's going to be 3. I'm going to take the base, which is 3, then to the exponent what? 2, the answer that we just get for our exponents, which is going to be 9, since we know that 3 squared is 9. This is how we simplify, guys. So let's try to do the last one. So yeah, we are going there, guys. We are going there. Okay, so this is how we simplify, guys. So let me rush to the other one. I think it's which I think it's a bit difficult. Check this one, guys. We're still simplifying, but I think here there is this one is a bit difficult here. So I'm simply going to be doing let me see, it's going to be long if I try to do this one now. So we're gonna end here for now. So let me just do the last one before we close. Then here I did not forget this part, guys. I'm still gonna come back for this one. For this part I'm still gonna come back definitely, because it seems it's a bit difficult. Okay, so let me do the last one before I close. So let's see, which one should I take here? This one, or this one? Which one is more difficult? Let me see. Okay, let me do number J. I think it's difficult. Let me do this one with the root. Okay, let me do J. So J goes like this. It's square root of 8 x6, the exponent of 4, like this. So this is how it is, yeah, because this 4 is not in the square root. Okay, so this is how it is. So as I've said before, guys, by the way, I think it's easy. It's also easy. Anyways, let's do it. By the way, I said, remember, okay, so let me write this one. Let me put this one in brackets like this, right? And we are going to assume that there is 1 here. So I'm going to take, so since it's 1, what I'm going to say, okay, so let's assume that this is 1. Then from there I'm going to write this as it is. So it's going to be x, it's going to be 8 x to the exponent x, right? We know that there is 1 here, right? So since it's 1 and I said this is 2, we have got a 2 here, on our root. So it's going to be this one goes on the numerator, this 2 goes on the denominator, like this. But let us not forget our exponent to the power of 4, like this. So from here you can actually let us find the prime basis of 8, which we know that's going to be 2 the exponent 3, x exponent 6, like this, 1 over 2, we are not forgetting 1 over 2, to the exponent 4, like this. From there, let us remove this first bracket whereby we are going to say we have 2, we're going to have 2 the exponent 3, we're going to multiply it by this one, 1 over 2. This one is a fraction, this one's not a fraction, you make it a fraction like this. Therefore it's gonna be 2. 3 times 1 is gonna be 3, 1 times 2 is gonna be 2. So it's gonna be our base down, then it's gonna be to the exponent 3 over 2 multiplied by x. Okay, for our x we've got 6 multiplied by 1 over 2, right? This one, it was a fraction, this one was not, you make it a fraction. Therefore 2 into 2, it goes how many times? Goes once. Then 2, this 2 into 6 goes 3 times, then 3 times 1, which is what? 3. It's going to be 3, like that. Remember, it is 2 to the exponent what? Of 4. Then from there, I'm going to multiply this by this 4, this by that 4 as well. So it's going to be 2, okay, on a piece of paper, 2, 3 over 2 multiplied by 4. This one is a fraction, this one is not a fraction, make it a fraction. Therefore 4 times 2, okay, 2 into 2 it goes once, 2 into 4 goes 2 times, 3 times 2 going to be 6, like this. Multiplied by x, 3 times 4, which is 12. So guys, this is how we simplify. So from there we are going to take our calculator, then write 2 to the exponent 6 to the exponent 6, which is 64. So going to be 64 x to the exponent 12, like this. So this is our final answer, guys. So this is how we simplify. Thank you for watching. Next time we'll be doing that part that we did not do because of I don't want to make this video to be that long.